Hello everyone, this is Mrs. Harding again. The activity that I'm going to take you through today is lesson 1.2a. You can see on the screen the learning targets for today. Make and interpret dot plots, stem plots, and histograms of quantitative data. We're not going to focus as much on histograms today, but I am going to show you a couple. The big concept here though is that we're switching over from categorical data to quantitative data and the different ways that there are to display it. Identify the shape of a distribution from a graph. Describe the overall pattern, including shape, center, and variability of a distribution, and identify any major departures from the pattern, which are called outliers. We're also going to compare distributions of quantitative data using dot plots, stem plots, and histograms. There's going to be a little bit of new vocabulary today, so make sure that you're paying attention to the new words that we're using to describe a distribution. Now, in a normal year, we would all go through and rank the value of statistics in our society, our opinion, and you'd tally your classmates' responses, and you'd put them here in this table. We don't have that data right now, so what you're going to look at instead is data from a past year, and I'll tell you what all of this is. This is called a dot plot, even though it's X's. And all you're doing is plotting all of the data on a number line. And repeated data just gets X'd above the other value. So in here, it was a scale from 1 to 9. So you can see the number line is done from 1 to 9. And there's an X representing every value that was collected from the class. So there was one person that rated it a 1, 2 that rated it a 2, 3 that rated it a 3, and so on. Some other pieces for you to notice about these, and these are details that matter. You need to be paying attention to when you make graphs, labeling your axes, so low important, high importance, and also titling your graph so that we know what the data is representing. One advantage of a dot plot is that you can actually see every single piece of data. One disadvantage would be if you had a very large data set, it would be a little bit time consuming. But this is what's called a distribution of data. We're showing how all of the collected values compare to each other. And we're going to move into a description of the data. So if you look at the bottom, we've got some pictures of histograms here. And there's different ways that you can describe these histograms, but there are some important parts that you should always include in a description of a distribution. And it says right here, shape, outliers, center, variability, and context should always be included. What we're going to start with is we're going to start with the shape. There's different shapes that a distribution can take. It can be symmetric, meaning the right and the left sides are pretty much the same. If you folded it down the center, it would be about the same on the left and the right. There is something called skewed right, and that's shown here. And there is also skewed left. And what you want to pay attention to is the direction of the skew is actually where the tail is. This is called the tail. It's not where the bulk of the data is, it's actually the direction that the tail is in. So symmetric, skewed right, skewed left. There's also what's called a uniform distribution where pretty much all of the bars are the same height. These are all descriptors of shape. Another feature that you could describe that has to do with the shape is how many modes the graph has. If you remember, the mode is a most common value. Those are identified in a distribution by the peaks in the graph. So if you look at the one on the left here, this would be called bimodal because there are two distinct peaks in the graph. This one in the middle, bimodal and skewed right. So there's two peaks here, but it does have a tail out to the right side. If there's only one mode or one peak, it would be called unimodal. So this one right here, we could even add in unimodal. Those are the descriptor words that you're going to use in describing the shape of a graph. Now let's take a look at this dot plot that you have. I'm not going to show you the whole answer just yet. But we're going to go through what you would say about all of these parts of the descriptions for a distribution. Shape, outliers, center, variability, and very, very important is that you're always including context in your answer. So let's start first with the shape. The shape of this appears to be unimodal and skewed to the right. Outliers. Outliers are any data that do not fall within the pattern of the distribution. And it does appear that there are a couple of outliers in this one, here at 5 and here at 6. The center of the graph. The center is where approximately the middle of the graph is. And in this one, you probably imagine that the center is somewhere in here, between 2 and 3 siblings. So we would say that that is the center of the graph. The variability. The variability is often called the spread of the graph too. And the thing that you're probably the most familiar with is the range. So here in the beginning, we're gonna quote the range as the variability of the graph. As you learn more about how to describe distributions, there are actually other terms that will become more important in describing variability than range, but this is where we're starting right now. So you can see the answer has all these things in it. It's skewed right. There are 2 outliers at 5 and 6. Notice that it's specific to where the outliers are. A center at approximately 2 to 3 siblings. And a range of about 6 siblings. One of the other things that is in here that's important for you to include is the context. And you can see that context was included here. The number of siblings of students in the statistics class. That's the context. Anytime you do not include context in the explanation or the description of a distribution, you will risk losing a couple of points. So make sure that no matter what you're writing about, you're always including the context. All right, so let's take a look at a comparison of 2 distributions. So now that you know what needs to be included in a description, all we need to do to compare 2 distributions is to apply those same things: shape, outlier, variability, and make sure you're including context and outliers. So in this example right here, how do the number of people living in households in the United Kingdom and South Africa compare? You have 2 dot plots, and we're going to compare the shape, the center, the variability, discuss any outliers, and make sure to include context for these 2 things. So if we're comparing shape, the shape for South Africa is more skewed right, and the shape for the United Kingdom, you could say symmetric or slightly skewed left. Both of those would be acceptable answers. There's a little bit of wiggle room on some of these descriptions. Outliers. It doesn't appear that the United Kingdom has any outliers. However, South Africa does have an outlier here at just above 25. So South Africa has an outlier, the United Kingdom does not. For the centers of the household, if you look for about where the middle of the graph is, the center is about 10 for South Africa and 4 for the United Kingdom. Now, sometimes when we go over these numbers for center, people say, well, how do you know exactly where it is? Well, the exact center is something that we'll discuss later. For now, you're making an approximation. It should be fairly close. But if you said maybe 9 instead of 10, that's still a fair answer. And for the variability is the spread of the graph. And looking at these 2 graphs, one thing that you should immediately notice is that the graph for South Africa is much more spread out than it is for UK. The UK is much more compact. So if we were looking at their ranges, the ranges of household sizes are about 23 and 4. 23 for South Africa, 4 for the United Kingdom. And then in your description also, always be sure that you are including context. So you can take a look at the write-up there. Okay, so what we're going to move on to is something called a stem plot. Some of you may have heard this called a stem and leaf plot in other classes. We're going to refer to it just as a stem plot. And this is another way to organize quantitative data. And it's similar to a dot plot in that you will get to see all of the data. And if you have too much data, it can be a little bit cumbersome to draw out. If you look at the example there, how many shoes? So they collected data from 10, I think it says 10, nope, 20 female students from the school about how many pairs of shoes they had, and the information is displayed there. And then they're going to take that information and they're going to put it into something called a stem and leaf plot. So a stem and leaf plot organizes the data by putting one place value as the stem and then building the leaves off of the stem. So in this case, everything is a 2-digit number. So what I'm going to do is I'm going to make a stem for the tens place. 1, 2, 3, 4, 5. 10, 20s, 30s, 40s, and 50s. And then I'm going to go through the data and place the ones place digit next to the correct stem. So this would be 50, 26 would be here, and so on. And then I would make sure that the leaves are in ascending order. So this here is the stem and leaf plot. And one thing that's really important is the key to a stem and leaf plot, and I'm not sure how clear this is on your screen, but that's what this is saying here, is that 4 and 9 represents the number 49. This is a stem and leaf plot. If we had a new data set, let's say that we went through and collected information from 20 male students of how many shoes they had, we could do the same thing. We could put these also in a stem and leaf plot. They're 2-digit numbers. We'll probably put the tens place as the stem, using a 0, obviously, for 7 and 5. And if you flip to the next page, you can see how that was done. Now, a couple of things to notice. When you put the data in here, there are a lot of leaves in the top stem. And it's a little bit hard to see, to visualize when there's a lot of leaves. So one way that you can deal with that and make it look a little bit better, a little bit easier to read, is something called splitting the stem. And that's what's done in this second piece right here. So that in the first part of the stem, I would have leaves 0 through 4. And the second part of that stem, I would have leaves 5 through 9. And so then you can see that a couple of features of this become a little bit clearer. It becomes a little bit clearer where the gaps are, and it becomes a little clearer that you have possibly a couple of outliers up here at 35 and 38. Now, a side comment about outliers, we will eventually get to an official definition of what makes something an outlier, but for right now, you can comment on any piece of data that's just outside of the general pattern of the distribution. So this again is what's called splitting the stem. You can describe a distribution from the stem plot also. So I could take a look at that and I could see that this is unimodal, skewed right, outliers potentially at 35 and 38, a center somewhere possibly around 11, 12, and the variability would be from 4 pairs of shoes to 38 pairs of shoes, so a range of 34. You can describe a distribution exactly the same way from a stem plot as you do from a dot plot or a histogram. In comparing data, you can compare data in what's called a back-to-back stem plot, and that's what's shown over here on the right side. So you can see that you need to be consistent with your stem, so we had to go back to the female data and we had to do a stem split here so that you could compare the two the two stem plots to each other. One of the things that can trip you up, even though it's a minor detail, so I'm just going to mention it really quickly, whichever data set is on the left, make sure you're numbering it from the inside out. And then also when you're going to describe the distribution, be sure that you know which is right and which is left. Larger numbers are the right side of the graph. Sometimes people will turn it the wrong way and say the females are skewed left when in fact they're actually skewed right. So make sure you just pay attention to a couple of those details when doing your descriptions. At the bottom of the page, there's just a few tips for making good stem plots. It says stem plots do not work well for large sets where each stem must hold a large number of leaves. We talked about that. There's no magic number of stems to use, but 5 is a reasonable minimum, 15 is a reasonable maximum. So if you start to get too many or too few, you might want to adjust how you're setting up your stem plot. One thing that you can do is you can actually use very large numbers in a stem plot, and you can just truncate or round the number. In the example there, $42,549 could just be truncated to 42,000, making it a little bit easier to put into the stem plot. This bottom one is another small detail, but I just want to emphasize it. If you're going to accurately display any information, make sure that you're including all of these pieces. If all I saw was a list of numbers and there was no title, no axis labels, no key or legend, I wouldn't know what any of that information was telling me. So make sure that you're always including all of those pieces in every plot that you create. All right, so at this point, a little bit off the screen, I would like you to pause your video, and I want you to answer this question here at the end, the check your understanding. So go ahead and pause, complete these last few questions. All right, let's talk about your answers to this. Do you remember what I was just saying a minute ago about the key being really, really important? You can see right here, they're telling you that 8.8 represents a state in which 8.8% of residents are 65 or older. It doesn't represent 88. So you really want to be careful to read the key when you're given one and to write one when you're presenting the information yourself. So in this first question, what percent of Alaska residents are 65 or older? Well, in here, 6.8, not 68. That is the lower outlier. What is the shape of the distribution? The shape of the distribution is relatively symmetric. If you said mildly skewed left, I would probably take that also, but the skew is pretty mild. The center of the distribution is close to 12%. Again, this is an estimate. If you wrote down 11.6%, 13%, that's fine also. The range of the data in the distribution is 10%. It goes from 6.8% to 16.8%. The big thing here is reading the key and knowing what the numbers are telling you. All right, your homework is on the calendar, and if you have any questions, please let us know.